in cycle theorem comes in paper 1. So this is from 2020, paper 1, question 17. So we're given this circle with a cyclic quadrilateral and other triangles inside. Then we have angle BAD, which is 47 degrees. Angle CBD is 28 degrees. Then we are told to find angle BOD, OBD, and BDC. So to find BOD is the angle at the center. So we'll find this angle by simply multiplying 47 by 2. We apply the theorem that says the angle at the center is twice the size of the angle on the circumference. So this angle and that one, they are standing on same points. So this one is simply twice angle 47 degrees. So you can say angle BOD equals twice angle BAD. So 2 times 47 degrees is 94 degrees. So this angle is 94 degrees. Then OBD, we are looking at this angle. So this angle is in a triangle BOD. And this triangle is made of 2 radii, OB and OD. And we know that the radii of a given circle, the length is supposed to be equal. So line OB is equal to OD. And because these two lines are equal, this is an isosceles triangle. And in an isosceles triangle, the base angles are equal. So since we know this one, we'll be able to know the size of angle B by subtracting 94 from 180, then divide the difference by 2. So angle OBD is equal to 180 minus 94 degrees over 2, which is, this gives us 86 degrees, then divided by 2, giving us 43 degrees. So angle OBD is 43, even angle ODB is 43. These two angles, 43 degrees, 43 degrees. Then C, we need to find the size of angle BDC. BDC is this one. We already know that, or we are given that this one is 28. We need to calculate this one. We can find this one by applying the theorem that talks about opposite angles in a cyclic quadrilateral. So this angle is opposite to angle A. So angles in a cyclic quadrilateral, opposite angles in a cyclic quadrilateral add up to 180. So to find angle C or BCD, angle BCD, we'll simply subtract 47 from 180, and this is going to give us, there were 3, 7 minus 3 is 4, we have 143 degrees. So this angle is 143. And since we know this angle and the other one, we'll take this as a triangle BCD. So we know two angles, we can add them, then subtract the sum from 180. So we'll say angle BDC is equal to 180 minus the sum of the two angles, which is 28 degrees plus 143 degrees. So 143 is 11 there, 6, 7, 171 degrees. 171 degrees is, we get 9 there. Then 7 minus 7 is 0. It's going to give us, okay, here we get a 1, 10 minus 1 is 9. Then we remain with the 7 here. 7 minus 7 is 0, 1 minus 1 is 0. So this angle is simply 9 degrees. So this is 9 degrees. Okay, so you just need to apply the theorems. The first one we looked at, angle at the center being twice the angle on the circumference. Then B, we applied the theorem OBD of an isosceles triangle. Base angles of an isosceles triangle are equal. Then C, we've simply applied the theorem about triangles, or on triangles. A triangle adds up to 180. So the three angles should give us 180. But then we only knew one. For us to find the second angle, we had to apply the theorem on cyclic quadrilateral, opposite angles in a cyclic quadrilateral. So we used that to find 143 degrees.